Once more, an immense scene is spreading out as we talk, enchanting stargazers all over the planet. Betelgeuse, the spellbinding red supergiant that decorates Orion's shoulder, is undergoing a vital change. This eminent giant, known for its marvelous red shade, has been a cornerstone of the winter sky for ages, drawing the awe and wonder of stargazers, from ancient civilizations to modern astronomers. What makes this change so extraordinary is not just the transformations occurring within the star itself, but the sheer scale and speed at which they are happening. This enormous star, significantly larger than our Sun, is demonstrating just how dynamic and unpredictable the universe can be. Betelgeuse's brilliance, the bright glow that defines its sublime presence, has surged beyond its usual brightness by an astonishing 50%. Imagine a light suddenly burning twice as brightly, casting its radiance further and with greater intensity. That's what is happening with Betelgeuse on a cosmic scale. At the start of this year, Betelgeuse proudly held the title of the 10th brightest star in our night sky. Its consistent, prominent light was a steady beacon in the heavens. However, this unexpected surge in luminosity has propelled it to a prestigious new rank, now shining as the 7th brightest star in our breathtaking night sky. This leap in brightness has sparked excitement and interest within the astronomical community, prompting groundbreaking observations and studies to understand the forces driving this sensational transformation. Betelgeuse, a massive star in its late stages of life, is of an immense size. If it were positioned at the center of our solar system, its expanse would reach as far as Jupiter's orbit. Eventually, this star will undergo a collapse, resulting in a powerful cosmic explosion that may form either a neutron star or a black hole. The anticipation surrounding Betelgeuse's cosmic explosion arises from the fact that it will be an extraordinary event. Positioned about 650 light-years away, humanity finds itself in an ideal location to witness this spectacular display firsthand. When the celestial explosion occurs, it will deliver a breathtaking display of light. Initially, there will be an unexpected burst of neutrinos sweeping across the Earth, detectable by observatories worldwide. Following this, high-energy photons will escape from the expanding cloud of stellar debris. Betelgeuse will rapidly intensify in brightness over 7 days, reaching up to 10 times its usual radiance. Depending on the explosion's impact, this celestial phenomenon could rival the brightness of a full moon and might even be visible during daylight, casting noticeable shadows at night. This magnificent event will last for an extended period, offering a unique opportunity for detailed observations and potentially groundbreaking discoveries. While Betelgeuse's explosion might provoke speculation and fear, historically associated with omens, we can take comfort in knowing that we are safely located at a significant distance, shielded from any harmful effects. To fully grasp the mystery of Betelgeuse, it is essential to revisit late 2019, when peculiarities began to emerge. During this period, the red supergiant star experienced significant dimming, a change noticeable even to the naked eye. Observations using the Very Large Telescope in the optical range revealed that Betelgeuse appeared mostly unchanged, yet its photospheric layers showed signs of substantial disturbance. The photosphere, the star's outer layer where light is produced, was expanding at a steady rate of about 8 kilometers per second for most of the year until mid-November 2019. At that point, the outward velocity began to decline. By mid-November, the flow of material from Betelgeuse ceased, prompting astronomers to capture new optical images of the star. Their observations uncovered 2 remarkable anomalies. First, a darkened region appeared in the star's southern hemisphere, contrasting sharply with a previous image taken earlier that year. Second, the star's surface temperature dropped significantly, plunging by approximately 80 Kelvin between January 27 and February 13, 2020. Betelgeuse's brightness reached an unprecedented low. About a year later, the star gradually regained its brightness, eventually returning to its usual luminosity. This led to the question, what had truly happened to Betelgeuse? Evidence strongly suggested that Betelgeuse had undergone a massive and rare event known as a surface mass ejection, SME. This phenomenon is similar to coronal mass ejections, CMEs, observed on the Sun. Imagine a volcanic eruption on a scale matching that of a star. Material from the star's interior surges outward, creating shock waves within its atmosphere. Over time, this material forms particles and dust, partially obscuring our view of the star and causing it to appear dimmer. In Betelgeuse's case, the SME released a mass 400 billion times greater than what is typically seen during similar events on other stars or CMEs, a mass equivalent to several times that of the Moon, ejected at incredible speeds. Scientists observed that such a colossal mass release from a star's surface had never been documented before. This event allowed for direct observation and analysis of surface details using the Hubble Space Telescope, providing a rare glimpse into the aging and evolution of a dying star. The SME significantly impacted Betelgeuse, causing it to lose a substantial amount of mass in a single event. This demonstrated that a dying star can experience dramatic mass loss beyond its usual yearly decline due to solar winds. In a sense, Betelgeuse had actively shed its outer layers and was slowly recovering from the aftermath of this event. Following this dimming episode, the star's behavior underwent a noticeable shift. Previously, it would pulsate or vary its brightness at regular intervals. Now, these pulsations occur irregularly. Betelgeuse is classified as a semi-regular variable star, meaning it experiences multiple cycles of brightness variations due to changes in its size and temperature. This red supergiant exhibits two primary pulsation periods. The first lasts about 400 days and is believed to result from pulsations in its fundamental mode. The second, a longer cycle of approximately 5.6 years, remains a mystery. To gain a deeper understanding of these events, researchers used computational simulations. They hypothesized that an unusually hot gas plume resembling a massive, extraordinary bubble rose from within the star. Such thermal gas bubbles occasionally emerge due to the star's convective envelope operation, comparable to a pot of boiling soup where the material is constantly churning and mixing. As this hot bubble ascended and broke through the star's surface, it triggered the ejection of massive amounts of stellar material. Interestingly, it also disrupted the star's usual pulsation patterns. The star's surface continued to expand while its deeper layers contracted, shifting its pulsation cycle from the typical 400-day period to a new 200-day rhythm. Astronomers anticipate that Betelgeuse's normal cycles will gradually stabilize, with the irregular pulsations likely returning to the standard 400-day cycle over the next 5 to 10 years. As for the possibility of Betelgeuse's supernova, astronomers estimate that it could occur at any time within the next 10,000 to 100,000 years. Based on factors such as the star's color, brightness, size, and estimated age, researchers suggest that Betelgeuse is currently in the early stages of helium-to-carbon fusion. This process will eventually progress through oxygen and finally iron before the star's core collapses under its own gravitational force, leading to a catastrophic explosion. Since Betelgeuse is located 650 light-years away, any supernova occurring now would only become visible to us 650 years later due to the constraints of the speed of light. Therefore, it is highly unlikely that we will witness the star's dramatic demise during our lifetimes. What makes Betelgeuse extraordinary is that we can directly observe its surface, something that is not typically possible with most other stars. This provides an incredible opportunity to learn more about how massive stars like Betelgeuse behave as they age, including rare events like these remarkable mass ejections. Recently, astronomers made another startling discovery: a star devouring its own planet 12,000 light-years away in a constellation. Betelgeuse, with its captivating name and prominent position in the night sky, has fascinated the human imagination for centuries. Its significance extends beyond scientific knowledge, influencing popular culture and folklore worldwide. Betelgeuse has a rich and diverse origin rooted in the Arabic language, originally translated as the armpit of the giant. Some researchers argue that it may refer to a hand or shoulder instead. This physical association is reflected in various interpretations of Betelgeuse, often linked to human or animal figures across different cultures and legends. In ancient Japan, it represented a severed limb, while in Brazil, it was viewed as a turtle's leg or a caiman's hind leg. The Sanskrit name for Betelgeuse means the damp one, tied to the Ardra lunar mansion in Hindu astrology and associated with the storm god Rudra. Since ancient times, Betelgeuse has played a vital role in cultural practices and rituals. For instance, in Macedonian tradition, it symbolized a severed limb. Betelgeuse's influence extends far beyond its role as a celestial object. Its presence in the night sky has inspired stories, myths, and even modern science fiction. In popular culture, Betelgeuse has been referenced in movies, books, and art, often symbolizing mystery, transformation, or cosmic power. Astronomically, Betelgeuse's ongoing transformations are a reminder of the dynamic nature of the universe. Stars, particularly massive ones like Betelgeuse, have complex life cycles filled with fascinating phenomena. Betelgeuse's unpredictable changes, from its dimming episodes to its dramatic mass ejections, challenge our understanding of stellar physics and offer unique opportunities for discovery. For scientists, Betelgeuse serves as a laboratory to study the final stages of massive star evolution. Its proximity and size make it one of the few stars where surface details can be observed directly. Observations from ground-based telescopes and space observatories like Hubble and James Webb have provided invaluable data about the star's behavior, structure, and environment. The future of Betelgeuse continues to be a subject of intense study and speculation. When it eventually goes supernova, it will create a spectacle unlike anything seen in modern history. The explosion will produce an extraordinary burst of light, neutrinos, and cosmic rays. This event will not only illuminate the night sky but also deepen our understanding of supernovae and the processes that create neutron stars or black holes. In the meantime, Betelgeuse reminds us of our place in the cosmos. Its brilliance, variability, and ultimate fate are a testament to the ever-changing universe and our efforts to comprehend it. The story of Betelgeuse is far from over, and as we continue to observe its behavior, we may uncover even more surprises that shed light on the life and death of stars. Whether we see Betelgeuse as a scientific marvel, a cultural symbol, or a source of inspiration, it remains one of the most captivating objects in our night sky. Its journey from a red supergiant to its eventual explosion will be remembered as one of the most remarkable sagas in the universe, a story written in the stars for generations to come.